Alright, good afternoon. This is Andrew CZ by the name Dre CZ on YouTube. Today we're going to do polynomials. Okay, so we're looking at tutorial sheet 4, MSM 111. Okay, so the first question says, use long division to divide use long division to divide that. So we have the dividend, then we have the divisors x minus 1. Okay, so short, if I can remind you, for example, if you have okay, so assuming that you're actually trying to divide 5/12 over 25, what we used to do is we first say what is 25 into 51. So that is 2, then 2 times 25 is 50, then we subtract 1 minus 0, that is 5 minus 5 is 0, so we don't write that. 1 minus 0 is 1. Okay, so 25 into 1, that's not possible, so if we bring down the 2, you have 12. 25 into 12 is not possible, so the 12 here is what we call the remainder, and this is the quotient, and this is the divisor, then this is the dividend. Okay, so we are going to apply the same principle over the same. So we're going to say this is the dividend and this is the divisor. Alright, so since we have the dividend and the divisor, we can simply write this as x minus 1, then we have x cubed plus 6x squared plus 7x plus 2. Alright, now if you look at this question which we've been given, we're simply going to first say we're going to divide only the x variable into the actual function which you've been given, or the polynomial that has been given. So we're going to say what is x into x cubed. Okay, so x into x cubed is x squared. Then what is x squared times x? This is x cubed. X squared times negative 1, this is negative x squared. Then just as we did before, we're going to subtract. So this minus that is actually 0. 6x squared minus, it becomes plus. So this is the same as 7x squared. Okay, next we're going to say what is x into 7x squared. This is going to be 7x. Then what is 7x? What is 7x times x? This is going to be 7x squared. 7x times negative 1. Here I have negative 7x. Alright, so here we can actually bring down this 7x so that we have plus 7x. So subtract, we have this minus that, which is another 0. 7x minus becomes plus 14. X into 14x, we have 14. Then what is 14 multiplied by x? So now notice that whenever we are actually multiplying, the division, only the x variable is going into the polynomial, but when it comes to multiplication, we are actually multiplying both the x and the negative 1. Okay, so what we now want to do is, we now want to multiply this 14 times the x which is there, then we have 14 times negative 1, which is minus 14. Alright, so here we can actually bring down the 2. Before we do that, so let's look at this. So we say 14 times this is 14x, 14 times this is negative that. Alright, now when x went into that, so let's write it like this so that you better see it. 14 times this was 14x, okay? This into that, so we have 14x here. Then 14 times negative 1, we actually have negative 14. Then this is why we bring down the 2. When we subtract negative, this is actually 0. 2 minus minus is going to be plus. So this is 2 plus 14, which is 16. Now, if you say x into 16, it's not possible because now we do not have any x variable with which the x can go into. So this becomes our remainder. So this is the remainder, 16. This is called the quotient, the one. This is the quotient, x squared plus 7x plus 14 is the quotient. And we have x minus 1. This is the divisor, and this is the dividend. Okay, so that suffices that question. Now, another thing, we can go up to question 2. Question 2 says, use synthetic division to divide the polynomials and write the function in the form px is equals to, let me write that. Alright, so it says use the synthetic division to divide the polynomials and write the functions in the form px. So we will need to write the function in the form px is equals to x minus k qx plus r. Okay, so now what you've been told is we need to use the synthetic. So we have a question here. I'll write the dividend side and the divisor side. X cubed minus 10x squared plus 13x minus 30. Then we have x minus 3. Okay, so that's the question that we have. Now, when you look at this question, what we've been asked for here is now we need to use the synthetic division to divide the polynomials. Okay, so this is what we're dividing in, and this is our divisor. So how do we use the synthetic? Okay, so for us to use the synthetic, the first thing that we need is we need to understand that x minus 3 is actually, is it a factor? Okay, so we want to know what is going to be the remainder out of this. So I'm going to say x is actually, x minus 3 is equals to 0. So x is actually equals to 3. Okay, so now I'm going to write my 3 here. Then I'm going to write the coefficients of the polynomial that we have. So here we have 1, negative 10, 13, and negative 30. Okay, so the first thing that we're going to do now is we're going to rewrite this one here. Right, then we're going to say what is 3 times 1. So all the time you have a question to do with synthetic, this is what we do. You need to always ensure that the first coefficient in the polynomial, the one with the highest power, the coefficient of the highest powered variable, is going to be rewritten under here. Okay, so we have 3 times 1, so now here's going to be multiplication and we are going to have addition. Okay, so the multiplication part, we're multiplying 3 times the 1 here, which is 3. Then we're going to say what is the addition of negative 10 plus 3. So we have negative 7. Then again we're going to say 3 times negative 10. Now we do not write the product exactly in the row or in the column with which we are multiplying. We write it vertically. Actually, let me just say this is diagonal. Okay, so an arrow there. So now we have 3 times negative 7, which is negative 21. Okay, now what is negative 21 plus 13? Negative 1 plus 13. So if you want, because of how the numbers are arranged, you can actually say this is the same as saying what is 21 negative 21 plus 13. Okay, so here, since this has the opposite sign, I can actually say this subtraction 21 minus 13, because they're going in opposite directions. The negative 21 is negative and the 13 is positive. So we have this, which is 11, 11 minus 3, that is 8. Okay, so we have 8. Then remember there's a 1 here. 1 minus 1, that's a. Now, it's supposed to be 8, but the question is, where is the negative coming from? The negative is with the 21, so this is actually negative 8. Okay, so now, what is 3 times negative 8? This is negative 24. Okay, negative 24. Negative 24 plus negative 30, since they have the same sign, this is the same as they are adding them, so this is 4 and this is 5, so we have negative 54. Okay, so if you look at this, this is actually the remainder that we get. Okay, now this part which you have here, this is actually the coefficients of the quadratic equation that results from this. Okay, so in short, if you are looking at the long division, you notice that we had the quotient, we had the divisor, we had the dividend. Okay, so now if you look at this question which we have, you actually notice that this part here is actually the quotient. Okay, so this is the coefficient of the quotient, where this is the highest powered variable, the coefficient of the highest powered variable, the coefficient of the second highest powered variable, and the coefficient of the 10th highest powered variable. Now, here, since we're dealing with a cubic function and we've divided, this has reduced to a quadratic function. So in short, what you actually notice, this as a quadratic function is simply x squared, then minus 7x minus 8. Okay, so this is what it is. So this is what we're calling our qx, which is the quotient. Then we have r, which we have here. Our r is actually equal to negative 54. Let me write it here. So we're saying qx is x squared minus 7x minus 8. Okay, then we have r, which is the remainder, as negative 54. Then apart from having the remainder as negative 54, we have something else which we need here, which is x minus k. Now, if you look at this x minus k, it's actually x minus 3. This is a constant, okay? So x minus k is actually equals to x minus 3. Right, so if you look at what we have here, writing it in this form, we are therefore saying px is equal to qx, so we have x minus 3 multiplied by the quotient, which is x squared minus 7x minus 8, then plus the remainder, which is negative 54. So instead of writing plus, we're going to say minus 54. Okay, so this here is what we have. Okay, that is the answer that you are being asked for. Right, so what are we saying? A recap. So we had the dividend side, we had the divisor side. Then here, since we're using synthetic, the first thing that we're going to do is we're going to say this particular, the divisor, we're going to equate the divisor to 0 there. So we had x is equal to 3, so this is the 3 I wrote here. Then here we simply say the coefficient of the highest powered variable should come down. So in the polynomial, so we had 1, then we are multiplying and adding. Okay, And then this is what we came up. So we say these particular three values here, these are the coefficients of the quadratic equation that we have. Okay, so in this case, since this was a cubic function, it reduces to a quadratic function. Okay, so this quadratic function which you have here, this is the qx which we are calling the quotient. The remainder is this one, negative 54. Then we had the x minus k which was given in the question. So x minus k is x minus 3. So now, picking all these together, what I've just done is I've actually decided to multiply this according to the question. So it says px should be close to x minus k, qx plus r. So this simply becomes px is equals to x minus 3. I'll replace this with x minus 3. The qx which we have in question is x squared minus 7x minus 8. Okay, so this is the qx, then we're actually saying plus r. Okay, so now do not make the mistake of saying minus 54, because after you multiply this, that's when you're subtracting the minus 54. So do not subtract negative 8 and minus 54. Okay, so that ends that question. Let's do a different question. Let's go to question 3. Okay. Question 3. Question 3. Alright, so over the same, before we even go to question 3, some people like to complain to say, we actually teach them how to cook rice, but we expect them to add soup. Okay, so what if the question actually came in soup form, where you don't just have to cook the rice, but you also have to add the soup? So let me give you a different question. We have the dividend side, and we have the divisor. Okay, so on the dividend side, we have 6x cubed plus x squared minus 21x minus 10. Then the divisor, we have 2x plus 1. Okay, so we want to write that in the same form. So what do we do? So now here again, as I said, the first thing that we're going to do is we're going to first ensure that we write 2x plus 1 equating this to 0. So 2x plus 1 is equals to 0. Then we're going to solve for x. So we have 2x is equals to negative 1 over 2 over 2. But in actual sense, you've actually added the additive inverse of 1 is negative 1 on both sides. Then here I actually multiplied by 1 over 2. Okay, so this is what we get. So let me write it like this. So we're saying this is 2x plus 1 minus 1 is equals to 0 minus 1. Then we have 2x is equals to negative 1. Then I want to get rid of the 2, so I'm going to multiply both sides by 1 over 2. So we are going to have this as x is actually equal to negative 1 over 2. Okay, because this negative, this 1 over 2 is multiplying both the 2x and the negative 1. So now we have x is equal to negative 1 over 2. Now recall what I said. I said we're supposed to actually write this negative 1 over 2 like that. Then we're going to write the coefficient that we have in question. So what is the coefficient in question? The coefficient in question are these. Okay, so we have 6, we have 1, we have negative 21, and we have negative 10. Alright, so the first thing that we're going to do is, as we said before, we are simply first going to say the 6 has to be brought back again. So as I said, the coefficient of the highest powered variable is rewritten. Then now we are going to multiply this by that, but as we said, it's going to be diagonal. Okay, so now if you follow this, we're going to say negative 1 over 2 times 6, which is actually 3. Okay, but since we have a negative, this is supposed to be negative 3. Okay, then 1 plus negative 3 is actually negative 2. Negative 1 over 2 times negative 2 is actually negative 1. Okay, so negative, negative, positive. Okay, then we now add negative 21 plus 1, which is 20. So we're going to write the 20 here. Then now we're going to say negative 1 over 2 times 20, which is actually negative 10. Okay, so negative 10 plus negative 10 is negative 20. Okay, so this is what we did. We first say let 2x plus 1 be equal to 0, then we ended up having x is negative 1 over 2. This is the negative 1 over 2 which I wrote here. Then we brought down the 6. Then we say negative 1 over 2 multiplied by 6, which is negative 3. Negative 3, 1 minus 3 is actually negative 2. Negative 1 over 2 times negative 2 is positive 1, so this is the positive 1 that we have there. Negative 21 minus 1, so negative 21 is negative plus 1, we are going to have negative 20. Okay, so since this is negative 20, we are now going to have negative 1 over 2 times negative 20. Instead of having a negative, we're going to have a positive 10. Okay, so negative is actually positive, so this is why we have the 10 there. So hence, we are actually going to have the remainder as 0. Okay, so now what does that mean? Whenever you find a question where you use synthetic division or you use long division, but you end up having the remainder as 0, that particular divisor is called a factor of the polynomial. Okay, so in this case we have 2x plus 1 is actually a factor of the polynomial because it has given us a remainder of 0. Okay, but that's not the question. The question is saying write it in this form. Okay, so now writing it in that form, what are we going to do? So to write it in this form, we are going to simply say what is x minus k in this case. So x minus k in our case is actually 2x plus 1. Okay, then we have qx. Now, what did I say? Qx is actually derived from the coefficients, the three numbers that you have. These are the coefficients of the quadratic equation that will result from this cubic function, because we've reduced this from a cubic to a quadratic. So qx now becomes 6x squared minus 2x minus 20. Okay, so that is qx. Then what is our remainder? Our remainder is 0. Okay, so this last number is always the remainder. Then this is the coefficient of the quotient. Okay, so now writing this in this form, we have px is actually equal to 2x plus 1 multiplied by 6x squared minus 2x minus 20. Okay, so plus the remainder, which is 0, but we don't actually indicate it. But in your case, I'm indicating it. So what does that end up being? So this is what we have. We've written it in the question that we were asked. Okay, so now we may not just be limited to synthetic division. We can actually have the same question too, but it can be asking us for a different form. It can say use long division. Okay, now if you are asked use long division, what are you supposed to do? Okay, so by use of long division, let me give you a question that deals with long division. Okay, so we've been taught we need to write the polynomial in this form. Okay, but now what we're using is we're no longer using synthetic, we now want to use long division.
the first concept that we use. So again, I'm going to write for you the dividend, and I'm going to write for you the divisor. Okay, so I'm going to pick a question from question 1. And the question I'm picking from question 1 in tutorial sheet 4, okay, is x to the power 4 plus 3x squared plus 1. That's the dividend side. Now, the divisor side looks a bit more complicated. X squared minus 2x plus 3. Okay, so this is a good example. This example simply shows you that you are not really limited only to having a variable in your divisor. Remember that in our previous divisors we had x minus k. Okay, remember this k can be any constant in question. If I can use the exact ones that we are just from looking at, we are going to use x minus 3, and we used 2x plus 1. So these were our two divisors, and the highest powered variable in these two divisors was x with 1. Okay, so now we're saying you cannot only be limited to this. We can have a question that can actually have a component of the divisor having a highest powered variable greater than 1. Okay, so in this case, since the degree is greater than 1, please, the concept remains the same. Okay, so I want to apply the exact same concept to the same question. So how do we do that? So I was saying this looks simple, this looks complex. Okay, so what do we do with such questions? So in order for us to deal with such a question, we're simply going to say the principle remains the same. Okay, okay, so what's the first thing we're going to write? So we're going to draw this as usual. So what is the divisor? So always the divisor is on this side. And what is the dividend? The dividend is x to the power 4 plus 3x squared plus 1. Okay? So now, please, the way I've written this is incomplete. Okay? Now, what's the first thing that you're supposed to do is, I know most of you people would directly write it like this. I've written it like this so that you know that it's actually not supposed to be written like this. Okay, so I'm going to make a change to this. It's not supposed to be x to the power 4 plus 3x squared. I know this is exactly what the question says, but in order for us to apply the general principle to this, we need to ensure that all the powered variables actually appear. So if you notice in the question, the highest powered variable is actually x to the power 4. Okay, so now since it's x to the power 4, this is a problem. Because x to the power 4, someone will say this is a problem because they are used to seeing x to the power 3. Okay, but I'm saying this principle is the same. Okay, so we have x to the power 4. But if you are changing the variables in descending order, what do you expect? You expect x to the power 4 first. The next powered variable should be x to the power 3. The next powered variable should be x squared. The next powered variable should be x, then lastly you expect to have a constant, because now it's as if the x powered variable is raised to the power 0, and we know anything raised to the power 0 is 1. Okay, so we are now going to talk about this in that regard. So I'm not going to write power 4, power 2, so I'm going to write the ones that are missing. Okay, so in doing so, we're now going to rewrite this as x to the power 4. Then the next powered variable, we can't see it, but it's there. So I'm going to say 0x to the power 3. From 3, what do you expect? You expect to have 3x squared. From 3x squared, the next variable which you expect to have is actually the one which is missing. You see, from x squared we've gone to 1, but from x squared, what is supposed to be there? An x. So we are now going to have 0x. Then we're going to say plus 1. Okay, so it wasn't as short as it looks in the question. Okay, so you can take a look at that. Okay, so if you actually follow what is happening in this question, you actually notice that we had quite a shorter expression in the actual question compared to the one that we now have in the actual one I've written. So what are we supposed to do? So here's what we're going to do in this question, okay? So we're going to say, what is x squared into x to the power 4? This is actually x squared. Then remember, division is only for the highest powered variable, but when it comes to the multiplication, we multiply the entire component with everything in the divisor. So we have x squared times x squared, which is x to the power 4. Okay, next, x squared times negative 2x. This is going to be negative 2x to the power 3. Next, we are going to have x squared multiplied by 3. So we have plus 3x squared. Okay, so as I was saying, this multiplied by that is this. X squared multiplied by negative 2x is negative 2x to the power 3. X squared multiplied by 3 is 3x squared. As usual, we're going to actually introduce the subtraction sign. So x to the power 4 minus x to the power 4 is 0. 0 minus, so we have 0 minus minus. So that actually becomes positive. So we have now 2x to the power 3. So what is 3x squared minus 3x squared? This is 0x squared. Okay, so again, we are going to ask ourselves, can this actually go into x to the power 3? The question is yes. Okay, so the answer to that question is yes. So we have x squared into x to the power 3. This is simply x. Then now notice there was actually a 2 here, so this will also have a 2. Okay, the essence of doing that is we're not supposed to just concentrate on the x variable alone, but also on the coefficient, because we want to replicate it. Okay, so it should be the duplicate of the one that we are supposed to see here. So you will see that when I multiply. If I say 2x multiplied by x squared, you actually have 2x to the power 3. You see? So it has been brought back exactly the way it was looking. So in this way, we can easily get rid of it. But that's just the principle of long division. Okay, there's nothing new that I'm doing. So we have 2x multiplied by negative 2x. We have negative 4x squared. Then we have 2x multiplied by 3. We have plus 6x. So now here, we're going to say subtraction again. This and this is 0. 2x cubed minus 2x cubed is 0. 0x squared minus minus, this is actually going to become positive. So we now have positive 4x squared. Wow. Okay, so now notice that this one is lonely. What do? We need to bring down the accompaniment. The same way that we're doing it under long division, we're actually going to do the exact same thing. Okay, the principle remains the same. What is that principle? Bring down. Okay, so we're going to say bring down the 0x. Okay, so now 6x is no longer lonely. Okay, so you can now see that we can actually say what is 0 minus 6. So this is simply minus 6x. Okay, so now again, 6 is x squared able to go into the other 4x squared? The answer is yes. X squared into 4x squared is actually 1. Okay, so now we have x squared into that is 1, but there's a 4, so we are saying x squared into 4x squared, this is actually plus 4. Multiplication is for everything here, so we're going to say 4 times that, so 4x squared. 4 multiplied by negative 2x, we have minus 8x. 4 multiplied by 3 plus 12. Okay, so again, here we're going to say subtraction. This minus that is 0. Negative 6 minus that becomes plus. So what do we have? Positive 2x. Okay, 2x. There's something that we've noticed again. The 12 is lonely. Okay, so what do? The lonely principle, give it accompaniment, bring down. So we are going to say bring down 1. 1 minus 12 is actually minus 11. Alright, so this is actually what we have. This part is the divisor, the quotient, and that's the remainder. Okay, so let me write them here. I'm not using long division, so what are we saying? We're saying the x minus k part is the divisor, x squared minus 2x plus 3. Then the qx is the quotient. So the quotient in this case which we have is x squared plus 2x plus 4. Okay, this is x. Then what is our remainder? Our remainder is 2x minus 11. So if we're going to write this in terms of px, we're going to have px is equal to, so we'll say this, x squared minus 2x plus 3 multiplied by x squared plus 2x plus 4 plus the remainder 2x minus 11. Okay, so that suffices it. So that's the answer to the question. So if you are asked the very question but you are being told now use the long division method to write your polynomial in this form, this is how we are going to go about it. So this is the application on of long division on actually a more complicated divisor. Okay, then you also notice that we had missing variables. So what did we say? In order for you to deal with the missing variables, what you need to do is you need to replace zeros in the missing variables. Okay, so the 0 is the coefficient of the missing variable. This is why you cannot say, remember, 0 multiplied by anything is actually 0. Okay, so this is why we actually have this being in that way. So I actually replaced 0. Here we said this was 4, the next one should have been 3, 2, 1, 0. This is in descending order, so the powered variables are supposed to be moving in descending order. But here it skipped, from 4 it went to 2. From 2 it skipped, it went to the constant. So what was missing? The power 3 was missing, and the 1 raised the power 1 was missing. So we had to include them using the coefficient of 0. Okay, then we used actually the normal long division method. So here we're saying division, we only consider the highest powered variable on the divisor. Then when it comes to multiplication, we actually multiply everything on the divisor. An example was given, so we had x squared into x to the power 4, which was x squared. Okay, now x squared was multiplied by the entire divisor to get to this. Okay, so we said x squared multiplied by x squared was negative x to the power 4. Then we had x squared multiplied by negative 2x, we had negative 2x cubed. X squared multiplied by 3, we had 3x squared. Then we simply subtracted to get to this. Okay, so when do we stop dividing? Whenever we're dealing with these sort of questions, we stop dividing when we notice that the highest powered variable can no longer go into the dividend. Okay, so in this case we had the highest powered variable, which was x squared, and we know x squared could not go into x. Okay, so this is the reason why we actually ended here, as this was our remainder. Okay, so this is the remainder, quotient, divisor. Alright, so that suffices that question. Whenever you're given such questions, this is the approach which is expected of you. Alright, so let's look at a different question. Let's look at a different question. Let's go to question 3. Question 3 is saying factorize the following polynomials completely. Okay, now of course remember we're now dealing with polynomials. We're no longer dealing with the quadratic. Of course, the quadratic equation is also a polynomial, but the highest degree there is 2. That's why it's called a quadratic, okay? Now, we have polynomials that are actually, whose degree are greater than 2. These are the ones we're dealing with. So now, when we're talking about the quadratic equation, what did we say? What we were taught was that whenever you are actually trying to factorize using the factorization method for a quadratic equation, we needed to find the product and the sum. Not so. So now, here is a cubic function. What do we do? Okay, so how do we deal with such questions? Let me write it down so that you can see. Question 1. This is 3. It says factorize the following polynomials completely. X cubed minus 2x squared minus 5x plus 6. Okay, so how do we factorize that completely? Now, in order for us to factorize completely, what we need is the principle of the factor theorem. Okay, in simple terms, how can we define a factor? In simple terms, how can we define a factor? Okay, so in layman's language, I'll say the numbers that can go into a number without leaving a remainder, those are the factors. Are we getting it? So in short, let's talk about a small number. Let's say 8. Okay, so what are the factors of 8? In short, what numbers can go into 8 without leaving a remainder? Let's just concentrate on the positive ones. Okay, so in this case, we know that the numbers that can go into 8 without leaving a remainder. So the factors of 8, in this case we have 1, 2, 4, and 87. So these are the numbers that can actually go into 8 without leaving a remainder. Okay, so any number, if we say leave without leaving a remainder, we are saying the remainder is actually 0. Okay, it's not that there's no remainder, but the remainder is 0. So whenever you have one of the factors, whenever you have the dividend over the divisor, and the divisor is a factor, the remainder will always be 0. That is what the emphasis of the factor theorem talks about. Okay, so now we are told we need to factorize this completely. So the thing is, we need to know what are the factors of this. We need at least one of them. Okay, so there's a formula which we are taught. The first thing is, let's talk about what are the factors. So let's note that there's a 1 here. Okay, let's note that there's a 1 here. So what do we do? Since there's a 1 there, we're saying the first thing is we're going to talk about the leading. Okay, so the leading here, meaning the one with the highest powered variable. What are the coefficients or the factors of the leading? So we have 1. So factors of 1. This is actually plus or minus. Let's do plus or minus 1. Okay. So what of the constant C? So we have the constant. The constant here is 6. So we're saying the factors of 6. Now remember that the factors of 6 can either be positive or negative. So we have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, then there's a formula that we have. Let's say that this is actually P and this is called Q. Okay, so we're saying the factors of the constant, we're calling them Q. That's Q, not QX, Q. Then we have the factors of the leading. When we say the leading, we're actually talking about the coefficient of the highest powered variable in the polynomial. So in this case, the coefficient here is 1. Okay, so here we're calling this as P. Okay, so in order for us to actually find, the formula is P over Q. Okay, so where P are the factors, so we're going to actually find, we're going to divide the P's over the Q's. So now, if that is the case, what do we have? We are going to say, okay, maybe to make it easier for you, instead of doing that, it's actually supposed to be Q over P. Hold on. So we're going to say, we're going to divide B's, which is the factors of the constant, over the factors of the leading. Okay, so here we have plus or minus 1. So now, when you say 1 into 1 is 1, 1 into negative 1 is negative 1. So you actually notice that when you divide this factor into that factor, or when you divide this factor into that factor, you're still going to have a plus or minus 1. So we have plus or minus 1. The next one is plus or minus 2, plus or minus 3, plus or minus 6, if you divide. Okay, now, from these here, we're supposed to pick a factor. So, the factor can be any of these. I'm not saying that when you use this formula, then automatically all these are factors. No, from these, the roots can be found. So, I'm going to try just one of them here. So, remember that whenever we actually replace this one here into the original function, if it ends up being a 0, then we know that that particular value is a factor. So let's try positive 1. Okay, so if I put positive 1, so I'm saying, let's assume the polynomial is actually given as P of x. Okay, so assuming that P of x is actually x cubed minus 2x squared minus 5x plus 6. Alright, then what you are asked for is, we want to know what would P of 1 be. So P of 1 would be 1 cubed minus 2, 1 minus 5, 1 plus 6. So if you want, you can say that. Okay, so this is how we write it. So we say 1 minus 2 minus 5 plus 6. So we have 1 plus 6, which is 7, minus negative 2 minus 5 is negative 7, 0. What did we say? The remainder theorem tells us that if you divide a particular polynomial, okay, over x minus k, if the remainder is 0, then that x minus k is called a factor. Okay, so now since we've replaced 1 into the polynomial and we've ended up having 0, what is the actual factor? So the actual factor here is not the 1. The factor is actually, we're going to say x minus k is equals to positive 1. Okay, so now here's how it's going to be. We know that we placed positive 1 to get to the value. So what is the actual factor? The actual factor is x minus 1. Okay, so but how do we ascertain that? We need to find the value of k. So we are saying x minus k is equals to positive 1. So now we are looking for the constant k. What is the k? Okay, so to find the k, okay, so we have x minus k is equals to 1. But what you actually notice is that the x minus k was actually already written for you. Remember, when we're using synthetic division, okay, you had this. You have a 1 here, or this is actually your k, okay? So this k here, how did we find it? We said x minus k is actually equals to 0. Then x is actually equal to k. Okay, so x is actually equals to k. So this k here is the one that we replace. So in short, for quickest way there, let me just say, when you find the number here 1, the factor has the opposite sign. Okay, so the factor is x minus 1. If this was positive 1, so the 1 here, I picked the 1 from here, replaced it in there, we ended up having a 0. So meaning, what is the actual factor? So we're looking for the factor. The factor is x minus 1. Remember, the k assumes the opposite sign. So if I say this is equal to 0, x is equal to 1, you see? So this x is equal to 1. This is the constant k. Alright, so this is the one that I replaced there. Okay, so for x being equals to 1, x is equals to 1, so what is k? K is 1. Okay, so we have now our factor is x minus 1. Okay, so we're going to use this factor to factorize this. We just need one of them. So now, usually what we use here is what is called try and error. Okay, since we do not really know what the first factor is, we're going to try one of these. So I tried the first one, and the one that gave me the actual factor is 1. So meaning that I can actually derive the others by virtue of using either synthetic method or the long division. So in this case, I'm going to use the long division method. So let me erase this. I know that synthetic is easy for many people, so this is why I'm doing an emphasis on long division. So what's the factor? We noticed that p of 1 was actually 0, so the factor that we had was actually x minus 1. Okay? So here, the divisor is x minus 1, which is actually the factor that we found. So we have x minus 1. Then what are we dividing? Please, the quickest way possible would have been the synthetic method. So x into that is actually x squared. By now I think we are getting the hang of how to do these things. So this multiplied by that, we have x squared, x to the power 3. This multiplied by that, this is negative x squared. Subtract. This is 0. Negative, negative, positive, so negative x squared. Okay, so what is x into negative x squared? This is actually minus x. Multiply this, we have negative x squared. This multiplied by that is negative x. So as I said before, you notice that the x is lonely, so we bring down the negative 5x. Then as usual, we do subtraction. Okay, so negative is positive, so this is a 0. Negative 5x minus plus, so this is just negative 4x. X into 4x is what? Minus 4. Negative 4 multiplied by this, we have negative 4x. Negative 4 multiplied by negative 1 is positive 4. Okay, so here I'm now going to bring down. Now, I want you to take note of something, okay? Many other times that people really get these questions wrong, not because they didn't know, but because of the manipulation of the signs, okay? If you look at this, you actually notice that there is something somewhere which is an anomaly. Okay, so in this case, when I multiplied negative with positive, yes, it was right. Negative x multiplied by that was negative x squared. But negative x multiplied by negative 1 is actually a positive. Okay, so you notice that I'm here, negative x multiplied by that is x squared. Okay, negative x multiplied by negative is what? Positive. Okay, so already this alters our result. Okay, so we have negative 5x minus x. So negative, this actually ends up being negative 6x. X into negative 6x is negative 6. Then when you multiply this times this, we have negative 6x from this, then plus 6, negative. Okay, so as I said, there's loneliness in the house. Okay, there's loneliness in the house, so we have plus 6 there. Again, I'm going to subtract, so you end up having negative 6x minus is positive, so these are opposite signs, but the same variables, it becomes a 0. 6 minus 6 is actually 0. Okay, so what do you notice from that? What you actually notice from that is that this is the quotient, then we have x minus 1 as a divisor, then we have the dividend, this is the dividend, then we have the remainder as 0. As I said, since the remainder is 0, this one is actually a factor. Okay, so now, this quotient here is what we also want to deal with now. Okay, so we're now going to deal with the quotient. If we use the synthetic method, you actually notice that this is going to give us the same thing. Okay, so by use of the synthetic method, what do you expect that would have been? So we are going to have 1. What are the coefficients in question? 1, negative 2, negative 5, and 6. Okay, so bring down the 1 as we said, 1 times 1 is actually 1. If you add these two, it's negative 1. If you multiply this is negative 1. If you add these two, it's negative 6. If you multiply 1 times negative 6 is actually negative 6. When you add this is 0. So we say this is actually the coefficients of the quadratic equation that results from this. If I write this, you notice that this is going to be x squared minus x minus 6. Exactly the same quotient. Okay, so I would have used the synthetic, I would have used the long division, both of us get the same. But that is not the question. The question is factorize completely. So how do we factorize completely? Now we are going to deal with what we have there, which is actually the quotient. Okay, so how do we do with the quotient? So I'm going to raise this. To deal with the quotient, so we're calling the quotient qx, and it's written as x squared minus x minus 6. So to deal with the quotient, what we're going to do is we're actually going to factorize it using the factorization method. So in this case, what is the product sum and the factors? So our product is negative 6. Our sum is negative 1. So the product, we multiply the leading coefficient multiplied by the constant, which is negative 6. The sum is the variable, the coefficient actually of the variable with the power 1, which is x powered variable with 1. Now remember, it's not always x. Okay, the letters can change. The letters can change. So it may not just be x, but the letters can change. So in this case, we're saying the highest powered variable, which is in a quadratic equation, will be x squared. Okay, the next powered variable, the one with the coefficient, the power of 1, that's the one we're saying is the sum. Okay, so here 1, so the 1 here multiplied by 6 is how we got the product, then we have the sum. Okay, so now product is negative 6, sum is negative 1. So now we want to know what are the factors, but factors of what? Okay, so the factors of what? Which factors are we dealing with? We are actually looking for the factors of, is it the sum? Or are we looking for the factors of the product? We're looking for the factors of the product. Okay, so the factors of the product in this case are possible factors of the product, what are those? We actually have 2 and 3. Okay, so I'm simply looking for two values which are the factors of 6, which when I multiply will give me -6, and when I add them will give me -1. Okay, so these factors which we have are 2 and 3. Okay, so I have 2 and 3. So, but what do we have? For the sum, we have negative. So, meaning when I add them, we should have a negative. And the product is negative. So, which one of the two is larger? 3 is larger, so we have -3. Okay, so from this, we are going to write this as qx is actually equals to x squared minus the factors. We're going to write the factors there. So, we have plus 2x minus 3x minus 6. Then, what's common here? The x is common. Okay, minus 3. Here we have x plus 2. Okay, so we have x minus 3, or we can say x plus 2. X minus 3. I factorize that. Okay, so now what is the factorization of this? So the other two factors that we are actually looking for are x plus 2 and x minus 3. If you are going to divide this factor and that factor into this polynomial, you actually find out that the remainder will also be 0. Okay, so our final answer therefore becomes, let's now say maybe the polynomial, I can call the polynomial as Rx. The polynomial being factorized is I'm going to simply multiply all the three factors. So the factors, the first factor we had was x minus 1. The next factor we have is x plus 2. The next factor is x minus 3. Okay, so if you multiply this the way they are, you actually notice that you end up having the original polynomial. Okay, so in an event that you are told to solve, okay, maybe if you're looking for a question and you're asked to find the roots, and hence find the values or the roots of this polynomial, what do? You simply say Rx should be equated to 0. So, meaning what you have is 1, -2, and +3. Okay, so this ends our tutorial on polynomials. Okay, so we were dealing with the synthetic and the long division method. Okay, so you can actually subscribe to my channel for more videos. All right, so the name on the YouTube channel is Dre, which is CzTembo. Okay, but it will show as Dre CzTembo. Okay, so subscribe to my channel for more tutorials. We are going to see you next time. See you.